Exportation, a rule of replacement. If P and Q, then R is logically equivalent to if P, then if Q, then R. Like other rules of replacement, on both sides of the four dots we have logically equivalent statements with the exact same truth table, which means that you can switch either one out for the other. The rule goes in both directions and applies to whole and partial lines. Exportation is the rule that describes situations where P and Q together result in R. If you've got the first two, you've got the third, whichever way you want to say it. This describes two-step processes, best of three series, agreements between two people, and so forth. To use this rule, switch the first operator between ampersand and arrow and back. Move the parentheses between covering the first two and covering the second two variables. Simple inputs, A, B, and C, can help us see how it works. If you have A and B, then you've got C, is the same as saying if you have A, then if you have B, you've got C. We can also use much more complicated inputs. We'll put in not A for P, we'll put in B and not C for Q, and either D or E for R. Well, if you've got not A and B and not C, then you've got D or E, is the same as saying if you've got not A, then if you've got B and not C, then you've got either D or E. It gets pretty complicated, but the principle is the same. Either way, our ampersand has changed to an arrow, and our parentheses have moved from covering our first two inputs to our second two inputs. When using this rule, the main operators, well, main and secondary operators really, are arrow arrow or ampersand arrow. The first operator switches between ampersand and arrow, and the parentheses move from covering the first and second variables to covering the second and third. This never involves V, not, or if and only if. As a rule of replacement, it applies in both directions to any whole or partial line. It cites one line and results in one line. We'll look at a few translations to see how this rule works, since it's one that we use in our everyday life all the time. If we win the first and second games, then we win the best of three series. Well, if we win the first game, then if we win the second, we win the best of three series. If I say yes and you say yes, then we agree. It's the same as saying, if I say yes, then if you say yes, we agree. Or if I turn the key and the car is working properly, then the car will start, is logically equivalent to if I turn the key, then if the car is working properly, it will start. Both sides, of course, have the same truth table. Since conditional is the main operator of both of these, the only way we can falsify either one is when a true antecedent leads to a false consequent. That only happens in line 1. These sentences are true in every other line, and since they have the exact same truth value, they're saying, as far as logic is concerned, the exact same thing. So they are logically equivalent. Let's take a look at how we might use this rule in a proof. Our premise says if P, then if not Q, then R. So we're able to conclude if not Q, then if P, then R. It might seem a little bit odd at first that the order of the P and Q inputs don't matter. If you've got both of them, then you're going to get to R. We're going to use exportation to say something like, if I win the first game, then if I don't lose the second game, I win the series. Results in, if I don't lose the second game, then if I win the first game, I win the series. Because commutation allows us to switch the order of P and Q to Q and P, we're going to be able to do something very similar around this arrow. But it's an arrow and the variables are separated by parentheses, so we need exportation first. That's exactly what we'll do. Here we've turned our arrow into an ampersand, and we've moved our parentheses from covering the second two to covering the first two. Now we'll use commutation, and we'll get the order right for our conclusion. Now we can do exportation yet again, this time from right to left to right rather, resulting in our conclusion. If not Q, then if P, then R. We've again switched ampersand to arrow, and we've moved those parentheses from covering the first to covering the second two. All we've really done in 3 simple steps is switch if P, then if not Q, to if not Q, then P. Let's take a look at a more complicated example, which is actually going to show us some of the limitations of exportation. You might be tempted to use exportation on both lines 1 and 2. Let's see if we can. Neither line is ready exactly. Exportation doesn't involve a V, and when it involves 2 arrows, the parentheses need to be around the second 2 variables, not the first. This line, however, isn't that far off. We just need to use transposition and De Morgan's. Let's try using this line. With transposition, we'll get our parentheses in the right order. If not D, then it's not the case that if A, then C. Okay? Well, notice that not. Exportation doesn't work on a negated conditional. That's just not in the rule form. So it's not going to work at all, it turns out. Let's just go back to line 1, and we'll do transposition, getting it's not the case that B or C, then not A. Well, it's still not ready for exportation, so we'll use De Morgan's to get ourselves an ampersand. Unlike the negation that covered the entire conditional, the negations surrounding sentence letters don't matter. You can do anything you want with these as far as exportation is concerned. So we'll go ahead and do that. We've gone from not B and not C, then not A, to if not B, then if not C, then not A. We've once again moved that ampersand into being an arrow, and we've moved our parentheses from covering the first 2 to covering the second 2. Now, by the way, we've gotten to a line where the antecedent of the conditional matches up with our conclusion, not B. Now we're getting a lot closer to being able to get to D. Since we just used transposition, we shouldn't be too surprised to see that we're not very far from getting to D. If not A, then C is logically equivalent to if not C, then not A. So we'll go ahead and apply that rule. Now that they match, we can do a hypothetical syllogism. I've included hypothetical syllogism here because getting that rule mixed up with exportation is absolutely one of the most common rules I see. You might want to use hypothetical syllogism to go straight from not B to C in line 6. But we cannot use hypothetical syllogism in that kind of situation. When both of the arrows are in the same line, it doesn't work. Let's take a look. Using hypothetical syllogism when you should use exportation can make a hard proof way too easy. And if something is too easy, it's probably wrong. And this, it turns out, is wrong. If X, then if Y, then Z does not result in if X, then Z. Hypothetical syllogism requires 2 unconnected arrows. They need to be separate. While the exportation form has one conditional that depends on the other conditional. Here, if X then Y, and if Y then Z don't depend on each other. So you can skip right past Y to Z. Here, however, if X then if Y then Z means X and Y result in Z. We have no idea whether X results in Y. Complicating things even more is that if X then Y and if Y then Z, so if X then Z, actually does imply our exportation form. If you have X and Y, after all, you are going to get to Z. But it doesn't work in the other direction. So this rule, exportation, cannot be substituted for hypothetical syllogism. They're covering completely different things that aren't entirely logically connected.